half-life of a substance is the time it takes for half of that substance to be gone. Break down or convert to another substance during the process of decay. Natural decay is modeled by this formula. So N of T is the amount that's remaining. So if we're calculating the half-life, that part could be 1/2 or 50% equals the initial amount, which if we're just using calculations would be like 1/2, right? If this was 1/2, then here would be 1/2. You got your base E, and then the exponent on the E, it's negative K, because K is the decay constant, times T, which is the number of years. So let's talk saber-toothed tigers. A paleontologist uncovers a fossil of a saber-toothed cat in California. He analyzes the fossil, concludes the specimen contains 15% of its original carbon-14 dating stuff. Carbon-14. Now, carbon-14 has a half-life of 5,730 years. You already knew that. Use carbon-14 dating to determine the age of the fossil. So we're going to drop some numbers into this formula. First thing we're going to do is we're going to find the decay constant. So we're going to use half-life in theory. So the amount remaining will be 1/2, or 0.5. Equals our original amount would be like 100%. It was the whole saber-toothed tiger. Then we got times E, and then the negative K. We're trying to figure out that constant. And the T, the time in years, for a half-life is 5,730. This will get us that constant of decay. So we have 1/2. Equals E to the negative 5,730 K power. Now we're trying to get rid of that E. That E is a problem, and we know how to do that using natural logarithms. So we can drop an ln on both sides, and that'll cancel out the E. So we have ln, not degenerous, equals negative 5,730 K. Now, 1/2 is like 2 to the negative first power, so let's rewrite it like that. And then let's take that exponent, that -1, and kick it out in front. So -1 ln2 would be like negative ln2 equals negative 5,730 K. Now we're solving for K, so we're going to divide both sides by negative 5,730. Negative divided by negative is a positive, so let me throw that in my calculator here. ln2 divided by 5,730. That will give us a decay constant of 0.00012. Ooh, fun. All right, so we're going to have to drop that back into our formula now. So now if we're trying to figure out how old this thing actually is, it said it had 15% of its original carbon dating, right? Yeah, 15%. So that's going to be our new amount remaining, 15%. It was 100%. And then we have negative K, which is our number we just got here, 0.00012 times the number of years, T. So we can go ahead, divide by 100, which will give us 0.15 equals E to the negative 0.00012 T. Let's natural logarithm both sides. So we'll have ln of 0.15 equals negative 0.00012 T.